All right, so hopefully you come back. Now, the easy, simple little answer here is I'm not going to do a print line here. I'm going to take it just and do a print. This isn't going to fix everything, but let's show you what it does at this point. 4, 5, 6, 7. So there's no space after it, but there is 4, 5, 6, 7. All right. So well, let's just do print plus a space. So let me try this again. We're going to make this incrementally better. I'm trying to build this as if we were doing it from scratch. Oh, so I hit the run button again, so the run one, which means again no big deal. You can see I printed 4, 5, 6, 7, 7, 6. This again, my tree's off. All right. So now I know I have something I can print any one level of the tree. So how do I print all the levels one after the other? Hopefully that's pretty easy. I do a for loop, right? So for int I is equal to 0, I is less than get height. Oops. Oh, just called height. Height. I plus plus. I'm going to print each level in turn. So I'm going to print level 0, then I'm going to print level 1, then I'm going to print level 2 by looping through the height. Again, I've hard-coded height, but when you get your real tree and you get your real height function, it should work pretty nicely. So let's see how it goes from there. Oh, it only printed 1, 2, 3. So it didn't print everything, and it printed all on one line. Okay, incremental. That's fine. I didn't plan for this, but I forgot about it. Why don't we do a system.out.println? I got to put a line between each level and see how it goes from there. So hopefully this now prints 1 on the first line, 2 on the second line, and so on. So let's see. Yes, 1 and 2 and 3, but it doesn't print 4, 5, 6. So what's up with that? Why isn't it doing that? Well, here we can see what's up with that. We can either use the debugger or I can use print lines. Maybe I'll do both. Let's start with the debugger here. Let me put this right here, and I'm gonna run the debugger. If you haven't run the debugger before, you just double click anywhere over here to add a breakpoint where you want the code to stop at, and then you hit the debug button, and it'll run until it gets to that point, assuming it does in the code, and then it'll stop. So at this point, you can see I is 0. Here's our control buttons. We can step over this call of this function, which we don't want to do. We want to step into the call of the function. So again, 0. Print line 0, subtree value, and it printed 1. All right. Now it's level 1. I'm going to step into this one. Then I'm going to use a step over after that, by the way. And the level's 1, so nope, I'm going to skip that level. And then I'm going to call print level of level -1. So let me go inside of here. So now the level is 0. And I print 2. All right. And then now I'm saying print level -1. All right. And then I print 3. I do a print line. Oh, so I'm saying less than the height. Right. So it stopped right there. That's doing it with the debugger. There's a quicker way sometimes. I mean, debugging is perfectly fine if that's the way you want to do it. But here's a quicker line, quicker way you could have made that happen. Let's just see how many levels it's looping through. All right, so I run this. 0, 1. So it's clearly not looping through the third one. And then I can jog my memory to say, oh yeah, well, it's got to be equal to the height. It's got to go all the way up to the height, not less than the height. It's not a standard for loop. It's a slightly different for loop. So let's try it again. Ah, there you go. Now that's printing what I'm expecting it to print. So we can go back to just a blank print line here and go from there. All right. Beautiful. So I have a good feel that this probably is working. If I wanted to test it further, I can. So let's do this. Let's do left.right.right dot left. And we'll make this one 8. I'm just putting this randomly inside of here. Let's see what it prints out, and then I'll try and figure out what's supposed to happen here. Oh, it didn't print anything out. Does that mean my code's broken? No, it doesn't mean my code's broken. Think about it for a second. Level 0, level 1, level 2, level 3, and I'm still saying the height is 2. I got to make my test case, my data has to be consistent before my code's going to work appropriately. I very well could have needed to debug that to figure it out, but it popped in my brain in that case that what I probably did. All right, so good news and bad news here. The great part about this code is you can see we're printing out everything on each level. The bad part here is I don't know where this thing's supposed to go. I have an 8, but I still don't know if that 8 is supposed to be the leftmost node or the rightmost node or where it's supposed to live. And because I put my values in improperly, I'm kind of confusing myself a little bit too, because it doesn't look like a tree, and hopefully I didn't confuse you so much. So again, I left this on purpose to make this point. We're printing a tree structure. We're not necessarily printing a proper tree structure with our code. This real simple little bit of code we put together has allowed us to at least see if we're putting things at the proper level, but they don't necessarily tell us where they belong left and right. So we can continue to evolve our test code and do a print structure to make it a little bit better, but to some degree, we can end up spending a heck of a lot of time to make this a very refined function. If you go actually search online for printing the full tree with lines in between everything else, it's a rather complicated function. So I want to add a little bit more to this, but I just want you to understand the limitations of what we're trying to do. I want you to build this. I don't really care what the function produces, so long as each level looks like a tree. There's one thing above one or two things above 1, 2, 3, or 4 things, and so on and so forth. It could be 1, 1, 1, 1, 1 if you have your tree that's a list. But I want you to be aware that I'm trying to get you to put something slightly fancy inside of here. Not super fancy, but just to give you a sense of it. So the problem with the toArray function is it shows you everything in order, and it can show you if it's done it properly. But when we move from basic binary trees to balanced trees, it's not going to help us know whether we're balancing properly. Now this will. This will show you basically for the number of nodes, it should stay very close to balanced as you're looking at the trees. So that's one of the reasons why I want to show this. So I want you to understand what the test is doing and what it's not doing for us as well. So let me fix this up a little bit. So let's switch 6 and 7 here. Oops. 6 and 7 were backwards, and I'll put these right. So left goes before right. And so now we said 8 is right dot left. So 8 should be the left child of 7, which would actually put it like over. Well, here, let me just copy this over. So if I really wanted this to be a better looking tree, what I would want it to look like is basically more like this here. And even better to spread this out a little bit. But, this is really, now it looks like a Christmas tree. So this is kind of what the tree would look like, because that's supposed to be where it's going to. That was an accident, by the way. It wasn't intentional. And even still with this, it's hard to tell if 8 is the right child of 5 or the left child of 7. And it appropriately shouldn't be either of these things. And I still have something messed up here. Root.right.left is 6. Root.right.right is 7. Root.right.right.left. Oh yeah, so I think this should be over here, but I don't know. Let me just double check something real quick. Yeah, so that's fine. It's always worth taking a moment to double check yourself. So left is 2, right is 3, left is 4, right is 5, right.left is 6, right.right is 7, right.left is 6. So wait, did that? It still seems to have printed that backwards. I'm not entirely sure how that's possible. And I don't know if that's my test case or not. And so this is a case where I probably want to go through and double check my code when I actually have my add method working. I'm not sure if I've done my test case wrong, if I've done my code is wrong. Um, and so let me just run this one more time just to double check myself. Yes, okay. I apologize. I I did correct it. I ran it before I corrected it, and I forgot that I hadn't run it again. Maybe you caught that. Just want you to see that sometimes even people with experience can kind of misinterpret. If your code and your data aren't aligned to the last time they run, sometimes it's worth just rerunning it to double check yourself. So I scared myself for a second. Say that should look right, and it didn't. This is how it should look, and it is proper at this point. So anyway, um, here's what I want to do. I'm going to pause this recording for just a second. This video is going to keep going, but I'm going to pause it, and I'm going to sneak in the rest of my answer code. I'm going to test that against this print structure to make sure this code that you're building actually works the way I want it to, and then we'll go from there. So I'm going to go pause this right now. All right. So I did a little bit of magic behind the scenes. I copied and pasted, and you can see all of my tests are passing now. So again, everything else is passing, but I actually haven't fixed my print structure. So if I just run my print structure, it still prints out my little test here. So what I'm going to do, now that everything else is there, I'm going to uncomment fill sets here. I'm going to actually fill the actual tree that I have going on. And then I'm going to comment out real quick because I don't want you to delete it. And you can delete it. You should delete it in your final code if you built this little tester. I'm going to comment that out, and then I want to test this for realsies. And we'll see what actually happens just to make sure. There might be something wrong here. So let's do run over here. That's better. Um, so when I run everything, there's other things that could be printed out. There's other places for print structure coming out. Now, I think this is looking right because you have J, A, Z, but again, this isn't 100% helpful because it doesn't show you the whole structure. So you have to imply some rules. So if J is the top one, then clearly A is to the left and Z is to the right, but that means everything else is in between those. So that means E is to the right of A. And then as it gets deeper, it gets a little bit more confusing. So this isn't a catch-all, fix-all, perfect solution. And you got to remember this is randomly generated, so I probably want to run it a couple times to make sure. But it generally does seem to be giving me a feel for what things I'm putting at what level. Now, if you want to double check yourself, I just want to point you to the very, oops, nope. If you pause it real quick, you can see some of the code. The very top of the test file here, there's this line 27 debug. I can say debug is true. And this actually, when I put debug in true, and I run this again, every time you run that fill method that we saw before, it tells you the order of which things were added. And there's like 100 of them in this case. So you can see the J was added first, the S was added second, the Z was added after that, the V was added after that, and so on. So you could very well modify this tester and do a print after every time something's been added. Or in your add function, you could just do at the bottom of your add function, every time something gets added, do a print and see everything as it gets added. So you can double check that. So I just wanted to give you the sense of this, that sometimes programmers write code just simply to make sure that other code they're writing works on the inside, even if that code isn't visible to anybody on the outside. The other thing I'll point out in this code, if I go to the print test, I have it printing 100 for test just to see it big. Change it if you need to. Start with 5. So I modify it to 5 and do something small. So Z, M, M, P, C. So Z gets added, M gets added, M gets added a second time, C and P. So all of these end up being to the left of Z because the first one added was Z. Run it again at 5. See if it's working here. 2 Q's that time. Wow, that's the odds of that. Oh, 2 H's that time. I guess the odds are pretty good. 3 times in a row. 2 Q's. Let's see if we can get one that's... yeah, there we go. 5 unique ones. All right, so we can see K was added, B went to the left, Q went to the right, I went to the left of K to the right of B, I think. So this Still relies on you to know a little bit, but it keeps our function fairly manageable. And that's why I want you to take a shot at it, earn a couple points for building this, and maybe help you debug it along the way as well as you're building your trees. Again, it may or may not help you much for the binary search tree, but I believe it'll help you quite a bit when you get to the balanced search tree. So consider doing it. And by the way, it's the same function in both. Once you get it working for one, you have it working for both. So hope this helps and have fun with it.